semester is almost over. So today's plan is to discuss section 7.4, and Wednesday we'll discuss the final that we're going to have next week on Monday. The practice shows the sooner I give it to students, the better. So I will email it even sometime Wednesday after class, so that way the plenty of time to finish the exam for some people, because practice shows that some people always need more extra time. So that's why I always try to send the exam early. So we're going to look at section 7.4, which discusses very interesting story about so-called claims. Turns out there are three types of claims that appear in statistical science. And first type, with respect to mean, that it is positive. And if you set this for so-called hypothesis, and they call it the H-index 0, that's standard somehow, then the opposite H-index 1 will be opposite to greater than 0, which is going to be smaller than 0, right? Less than or equal to 0. So there are three kinds of statements you can create of this type. You can say it's greater than 0, mean, or less than 0. So the opposite will be the opposite to less, which is going to be greater than, right? So write it down, H1. Oh, that's very nice and thick. That's too thick. H-index. Why is it so thick? It's not supposed to be this thick. Let's see. Why is it get so thick? I don't understand. Make this greater than 0. Not sure what happened. What is I clicked? So it started to be that extremely thick. Oh, here it is. Okay, now I got it. So if it's greater than or equal to 0, so less than 0, the opposite is greater than or equal to 0. You say, Alex, that's messy. Maybe clean this and write it the way it was. I know it may start have people wondering what is going on H1, which is greater than or equal to the opposite. Or the third possibility, where you get the case when it is equal to 0, H not is equal to 0. Well as comparing to 0, you can compare it to any value. Remember when we were using the case with standard normal distribution, we started with 0, and then we could use any scenario using tables. We were able to convert. So what's the opposite to equal? Not equal. Not equal means it's either less than 0 or it is greater than 0. So we have two possibilities for not equal. So the point is there are three possible claims, either greater or smaller or equal. And that equal breaks into greater or smaller on the so-called both sides And now I'm going to make pictures, my favorite pictures. So it turns out I always make a picture of H1. So if it's less than 0, then it is here. Or if it's greater than 0, then it is, well, on the right side. And the last case, when it is not equal to 0, it's on both sides. So it could be either on the left or on the right side. So in all exercises, problems will go under one of these three possibilities. There is nothing else, and that's what I want to try now. I want to try the problem to show you how the test of various claims is possible. So for that matter, I'll just take the problem and try to test it. So let's say Everglades temperature, exercise number 9, to get everybody excited, the nice and warm Everglades in Florida. So they say they measured at different times. For some reason, they decided to go with degrees of Celsius. Okay. You can always convert Celsius to Fahrenheit if you want. But it says mean is 30 degrees obtained for 61 temperatures. So if I remember, we have letter mu and sample size 61. Please notice then if you have a sample size, that's your sample mean then, because that's sample, not mu, not population. So 30 point is sample mean. That's what they give us. And then they also say standard deviation is 1.7. So things that we already encountered, mean, standard deviation, sample size. And then question comes, test the claim. And then they can claim anything they want. So they say the mean is greater than, so population mean, which is mu. Notice claims are always about population. So you study some sample, and then you want to make, based on that sample, a decision about entire population. So they say greater than 30 degrees. Okay, you can claim anything you like, but here is the start. So they claim something, we want to test it statistically. So how to test it? First of all, notice this is going to be like we had already in the first example here, the story of claim, which is greater than some number. So I set hypothesis, put my claim greater than 30 in it, and then I need to go for the rest of this story. I need to go for the opposite. The complement of greater is less than or equal to 30. It's always like that. And then we have a picture, so basically a copy what I already had, greater than 30, so it's somewhere on the right side. So whatever 30 is, so somewhere probably in the center, and we need to go to the right because, oh, sorry, I need to go to the left. I always make a picture of H1. I think I didn't wake up yet, even though it's already been plenty of time, but I just still asleep. So we'll always make a picture of H1, and it's shown here. So it has to be on the left side. H1 is always the case. So that's standard setting for all the exercises. That's how they go. So H0 and make a picture of H1. Please notice that H1 is always going to be a little tail, and then we need to test at so-called 0.05 area, or they call it here as level of significance, the area of 0.05 is cut by the z-score. And remember how we used to find the z-score? We used to go for the favorite tables, right? Tables, I emailed you the link to it, or you could just type Triola tables, right? And in these tables, and now I need to find the area, 0.05. So among the areas, I have to locate the closest to the one we have. And if you start on the top and keep going down, you will see where 0.5 is supposed to be. 0.505 and 0.495. So between 40 and 50 is 50, exactly. It is right in between. Remember, there was an asterisk. So what I do is follow the arrow down and see it's 1.645 with a minus sign, right? So it is right here, 1.645. And that's just what I need in here. So I'm going to be using that number 1.645. Right? So that's so-called cutoff value that they want to associate with, well, area in the tail of 5%. It's a standard number. We already saw it, right? So very popular. So anyways, what about the test? So now we have done some study. We have some information. And what we do is we calculate the z-score, which is x minus mean divided by a standard deviation. And not just standard deviation by the square root of n in its denominator. So we need to use the stuff that we have here, 30.4 for the sample. Then what I need to subtract is population mean. So it turns out the only choice I have is 30. It's always coming from the hypothesis. That's one little extra fact this section is discussing. So now I have parentheses around numerator, and denominator is also going to be inside the parentheses. 1.7 is on the top, standard deviation, over square root from 61. Okay. 61 is on the top. So I will calculate that z that comes from sample, and I see where are we? We're in the area that belongs to a region called H index 0, or we're in little h1 that starts at this particular z-score. So what's the z that we can get from our sample? So I get my favorite calculator and put the numbers in. So we already did this numerously. 30.4 subtract 30 on the top divided by 1.7 divided over square root 61. Okay, so I got the value for my particular calculation. It is 1.83. That's the result. So 1.83 is someplace here, right? So it is an area called H0. So I'm there. How can I declare it? I say, yes, I'm in the H0 here, and I'm not in the opposite, in H1. So we just did a big deal. We just supported our claim. So they claimed that we have average more than 30. And so we did. We saw that the average is definitely more than 30. It's 30.4 from the sample. It definitely supports the fact. It is not less because we did the study and we saw it is. They say, Alex, but why do you need that? You found the average more than 30, then you get the answer, yes, it is more than 30. So why do we need that claim? Well, we proved it statistically. That's the whole point of this procedure. So we statistically show that indeed, for the study of 61 elements, we have it done with a probability of 95%. So if area of your little region here is 5%, the opposite side is remaining 95%, right? Not that region. And we are 95% sure that this is correct. So it looks like it's the same old stuff, the formula we used, but only a little extra is in terms of adding word claim. And again, you can claim just about anything and produce the process. So I can do it again in exercise 10. Well, just to see that we're gonna repeat this whole thing once again. And please notice we made a big decision. We made proof that average temperature in Everglades, Florida is more than 30 degrees. And that's it. I say, well, I don't care for Everglades. Well, but depends on what study you're trying. For example, if I try number 10 that deals with weights of bears, so interesting example, right? How about weights of bears in Yellowstone Park? It says 54 bears have mean weight 182.9. So start is exactly the same. In fact, in all exercises here, start will be the same. They give you the sample, size 54. The average for the sample mean it's value of x with a bar. It's not a mu, it's x with a bar is 182.9. So somehow they measure weights of those bears and they want to know what happens with entire population of bears. So they were able to catch and weigh 54 of them, but there may be way more. So they want to know the average. So standard deviation, they say, is 121.8. You can also find it from your sample. So you now need to test the claim at 10% significant level. Test the claim that population mean is less. So I say word claim. Yeah. Mean is less than 200 pounds. I say, Alex, yes, looks like you will get that again supported because your mean is 182, so it is less indeed. Yes, probably, but again, let's do the calculation to support it statistically. That's the whole point. So we call this as H index 1. And actually, I want to put that H1 here. So H index 0 will be the opposite, which is greater than or equal to 200. So 1 and the opposite is here. So I'm going to make a picture of the 200. How? Well, less than 200, less means on the left. I'm going to say, where did you put 200? I don't put 200 anywhere. I put z-score. I need a cutoff for the case of 10%, 0.1 or 0.10. So 10%, that's the new value. They give us a significance level. And for that particular value, I need to use tables. It's actually 0.1000 is what I need. And you say, Alex, why it is 0.1000? Well, because I looked at the table. So if you look at your tables for the normal distribution at the area page, you will see they all have 4 significant digits, right? So if I need 0.1000, I start on the top and go down, and I see it starts to increase, and here's 0.1000. 1,300, so I need to probably be in the upper row in the next row above, because when I keep going, I'm smaller. So here's 1,020, 1,003, it's somewhere here in between. Let me clear the previous mess so I can better see what's going on. So it looks like 0.1000 has to be in this row. It is in between 1,003 and 0.985. See that? It's row next to -1.2. Let me bring this down a little bit so I can see the column, right? So once again, I'll go in for the -1.2 here, right? Because the numbers I care about right now are here. In between of 985 and 1003, and looks like we are closer here to 0.8, right? Remember, we already saw this once, I think. We did the problem with 0.1000, and there was a 1003, only 3 steps from 1,000 to the left, but the other number, which is 985, was 15 steps. So closer was 1,000. The closest wins. So we take row 1.2 and the column 1.8. So that'd be negative 1.2. So the area and the cutoff for it, and then the z-square that we already saw the formula for. So I just need to use all the data given to me here, 182.9, and then you subtract from that number mean, which is 200. I'll try it here. And then I divide this by a standard deviation, which is 121.8, or square root from sample size 54. So our z-square, well, again, is being calculated. That's why I decided to select this section, because we're already familiar with pretty much everything in it. But exciting part is the fact that we can test all kinds of claims. And that's pretty interesting. So you can claim things, whether it's correct claim or incorrect, because somebody can say, no, Alex, I think weight of the bears is more than 5,000 pounds. Okay, you can test that claim. So whatever a person claims is going to be tested statistically. So people are free to claim whatever they like. But some claims may be correct, some maybe not. So 182.9, make sure you enter exactly the numbers they gave you. Or if you do the calculation, make sure you enter your correct numbers. Otherwise, you can get all kinds of answers. So divide by square root 54. So double check what is here, what is entered, and see your number. See your number. The number is 103 with a negative sign. And this is very interesting. Where is this number coming to? In what region? H index 0 or H index 1? Please notice it's 103. It's here. It's an H0. So you say yes to H0. As usually, whatever the number is in, you say yes. The opposite, you say no. But your claim happened to be in H1. They decided to claim it's less. So it is not less. I say, how come it's not less? I found the sample mean was 182. Yes, it was less, but not enough to support your claim. To support your claim that it is less than 200, it needed to be much smaller than what you have. So what did I just prove? Well, the weight is not less than 200. It is probably greater. That's all it is. And if somebody can say, well, so what is the actual weight equal to? Well, you probably need to set another claim. Maybe it's not less than 200, maybe it's less than 210 or something bigger. So you can think about it. If you're working on that type of research, you probably can wiggle some numbers here, but it's not less than 200. And I guess the key reason is standard deviation is big. So some bears weight less than 200, but some of them, look at that standard, 120 and 180 is 300 pounds. So some bears are bigger. Some of them are, because of standard deviation, they're more than 300 pounds. So it's definitely not less than 200. So it is not correct. So there are various little ingredients in here, but it's all being done by calculating z-score. So when you start to think harder, you will see why this is not working, but you don't have to. It's enough to just test the claim and either say yes or no to it, and that will be all. And it is all. That's all I wanted to discuss today. I know it's already last week. I know that you're probably trying to put things together, and I will ask you to please email me your homework. I say, Alex, homework? Yeah, whatever we do in class, just choose the problem, let's say choose problem 10, copy it, and that will be your homework. And from the previous little lecture, choose also the problem I did. And when you say, how can I choose the problem? I wasn't here for weeks and months, and I have no clue how to choose them, where to find them. Well, I emailed you everything. Did you know that I sent you emails of all lectures that we had for our class? And if I look at my sent items and go to
Do we send the homeworks like before the final? Would you prefer?
Yeah, just like what you did for the midterm. So
Okay. I mean like in these next days?
yes. So when
Okay.
we were done with the midterm exam, I asked you to email me homework. So you did it, great. So now after the midterm, we had a few lectures. So analogously to this, you should select a problem from each lecture. So there are various links here. So just click on, I'm not going to click on it, it's going to open. And in those links, you can select only one exercise and copy it. Or if you like to select more, it's even better. So that'd be called homework, right? So you just remember what we did a little bit. and email it to me when. Well, preferably before the final exam. Final will be next week. It's scheduled for Monday. If you need more time, if you're busy or whatever, that's fine. You can send it to me on Wednesday or anytime next week. It's fine. So you can just email me pictures of your work. So as you just mentioned, same as for the midterm. When you say, Alex, I didn't send you any homework at all. Well, you have a chance to send me everything. So just select problems. I have it all here from the very beginning of the semester, I think. But anyway, just start sending me.
One more question, please.
Please.
Do you want the assignments starting from the chapters that we took after the midterm, or do you want after the midterm?
Yes, you don't need to send me.
Yes, so that's for assignment chapter 2.2.
Yeah, I don't think it's going to make sense to send me the same thing again, right? So for statistics, we started with statistics after the midterm. So just from this textbook, the lectures, yeah, that'd be good enough. That'd be good enough. If you already have it, you can even send it to me tonight. And if you need more time over weekend. So whenever you're done, please email it to me. And next time on Wednesday, I will discuss the midterm. I'll do another exercise from this section that we looked at. So it turns out the good thing about statistics, the problems in these sections are all the same. So you know how to do one, all of them are the same, just different numbers. That's why I just ask you to copy one and email it to me and copy another one from another section. And that should not be too many. We had after the midterm about 10, 11, some meetings as well. 10 problems should be good enough. Okay. So I'm glad you remembering what we did for the midterm and hope anxious to email me your homework. That's one part. And the other part will be the midterm. It will be pretty much the same as the final exam. So it'd be the same as midterm. I'll ask two questions, and next time we will discuss exactly where those two questions are coming from. So you will know for sure what to expect, what to concentrate on. Okay. So please, I guess, start to put your homework together. I'm gonna email you a recording of this lecture after we finish for today. And now I'm waiting for your emails. All right? I'm gonna stop recording. Recording.